Good morning.
Good morning.
It's a great honor to be back here. I love visiting Seoul. First of all, being from Texas, I love spicy barbecue, and you have some amazing barbecue here as well.
Cool.
Okay. So today I wanted to talk to you about a concept that I'm calling the algorithm economy. Now, as Jasek pointed out, I am on Twitter, Sparky Collier. Feel free to follow me if you like Twitter. So, algorithms. What is an algorithm? Probably all of you are familiar with this term, but you may not be aware that it actually conceptually was created by a mathematician in Baghdad over 1,000 years ago. Simply put, an algorithm is a procedure or a formula for solving a problem. And so, if this has been around for over 1,000 years, why do we want to talk about it today? And why here in Korea? Well, first of all, there are several big trends going on right now across the world that are fundamentally going to change and reshape our society. The whole world is going to look a lot different in a few years than what it is today. I don't think we'll even recognize it because of how powerful these forces are. And many of them are about accelerating algorithms and the impact they will have on our economy, our society, and our daily lives. But first, to talk about the trends. We have very powerful computers, distributed systems that are only come online in the last few years. And what I've actually showing here, last week, I was lucky enough to go to the University of Texas in Austin to their supercomputer center. And this supercomputer is called Stampede because the Longhorns are the University of Texas mascot. And I put this in here specifically to honor Jasek because he went to UT in Austin, University of Texas, and and if you'll notice, this computer actually has Longhorns on the top of the rack. These are from an actual cow. So the one thing we love more than computers in Texas is beef. So we really believe in the Longhorns. So that's for you, Jasek. We think about executing algorithms. Obviously, massive computational power makes a big difference. Secondly, ubiquitous connectivity. This is a trend that you should be very familiar with because if you'll notice, it's a hard chart to read, but I'll give you the headline, which is South Korea is #1 in 4G connectivity speed. So congratulations. You don't know how good you have it. It's you're very spoiled for great speeds here. But when you combine the power of computation and the ability to store, process, and move data with ubiquitous connectivity, that's a very powerful thing. And it actually lets you take the fundamental concept of an algorithm, which is to solve a problem, and allows you to solve more problems. And when it comes to connectivity, 5G is coming next. I think you'll be hearing shortly from SKT about the pioneering work they're doing in the OpenStack community and in the telecom industry to bring 5G. And I heard an interesting quote recently that the difference between 4G and 5G is IoT. That's a lot of acronyms, but Internet of Things is really about connecting lots of sensors, connecting transportation, automobiles, and I'm going to talk about a lot of those examples here today. And of course we know 5G will be faster, but it's not just about speed, it's about what you can do with broad connectivity. And I look forward to hearing from SKT in the next talk about some of the things they'll be doing with that capability. Another big trend are cheap sensors, basically computation that is very easily to afford and can make computers at the edges in our lives embedded and very accessible. This is the latest Raspberry Pi, which costs only $5, which is about 6,000 won. And it's got 200 times the processing power of the first PC and 800 times more memory. So That's a huge economic disruption. So when you take these computers and sensors that are becoming very, very inexpensive, you connect them to 4G and 5G networks, and then you process lots of the data they collect in these cloud computing distributed systems, that really gives you the power to solve problems through this algorithm economy. And lastly, cheap energy. Data centers take a lot of energy to run, and I think anybody who's following the markets may have noticed that oil has gotten a bit cheaper lately. But I think in the long run, it's actually solar adoption that I'm most excited about. This is a really positive trend for humanity, in my opinion. And not surprisingly, if you know much about economics, when the price or costs have gone down, the usage has really skyrocketed, and that's what this data really illustrates. So we're starting to see a meaningful amount of the world's energy captured by solar. There's a lot more to do, but I think this is a very positive trend. And in terms of the business opportunity, this actually illustrates how big of an economic impact artificial intelligence will have. And artificial intelligence, or AI, is one aspect of the algorithm economy, and machine learning is another example that I'm going to talk about next. So the Harvard Business Review, they studied machine learning, and they said that this is going to fundamentally change every business process, and the whole concept of how value is created in the global economy. And the thing about machine learning is not just what algorithms you put into the machine, but actually how it learns from data and gets smarter over time. So the algorithms essentially create new algorithms or adapt and grow. And that's a very powerful thing. And so the idea of a thinking machine is still a bit science fiction to a lot of people, but we're starting to see some pretty interesting examples where algorithms are actually starting to compete with human beings on some pretty complex tasks. And so a lot of these things may seem like they're years in the making, but we're starting to see some real examples. So first of all, how many of you are familiar with a game called Go? All right, well, you all should play. It's a very interesting game. So this has been around for many, many years, and it's a very complicated game. Many of you may have heard that certain computers, like the IBM Watson system and others, have started to become quite good at chess, but Go is actually more complicated to master for a system. And Google recently announced that they've developed an algorithm that has been able to beat almost every one of the best Go players in the world. And so next month, right here in Seoul, we'll be finding out if it can beat the world's best Go player. So you may not be familiar with Go, but you happen to have the best player in the world right here in Seoul. So I wish him luck against the Google machine.
Human will win.
What's that?
Human will win.
Yes.
We beat the Google.
The human will win. Okay, that's good. Place your bets. I'll be.
Bet on Google.
All right, we'll bet for a barbecue in Austin. How about that?
Sure.
Okay.
Deal.
All right, everybody, make a note. So, transportation, something that affects all of us. You may have seen recently that Tesla has released one of the first autonomous driving vehicles. So they actually took their existing models of their car and pushed a software update in the field down to the car to allow it to drive itself in certain circumstances. This is the very beginning of autonomous vehicles. But this is possible because the car has many sensors, cameras, radar. It can look for other cars around it and avoid collisions. It can actually read the lane markers, and as you go around a curve, your car will actually steer itself. And so that's an example where an algorithm is starting to learn how to do some of the most complex tasks. And if you can imagine 10, 15 years from now, cities filled with autonomous driving vehicles, that's a much different world than we live in today. And in the commercial side, this has actually been happening as well. So there's a large company that ships a lot of food around the world in trucks, and they recently installed a system that helps detect pedestrians and other vehicles to make sure that the delivery trucks are keeping a safe distance. And they actually saw a 50% reduction in collisions and other unfortunate accidents based on these systems that are able to keep an eye on the road for you and alert the driver. So that's really making a big difference in our everyday lives already, just from these intelligent systems and sensors. Next, I'm not sure if our translator will actually want to tell you what this one is. Unfortunately, or fortunately, depending on how you look at it, within 10 years, people are predicting that you'll be able to have simultaneous translation through an in-ear piece through the magic of algorithms. And as someone who travels around quite a lot and talks about OpenStack and cloud computing, and unfortunately doesn't speak as many languages as I probably should, this may come in handy. Lastly, in terms of our everyday economy and life, agriculture, everybody has to eat. The production of food is something that is a major area for innovation right now. This particular company is a startup in France, and they have embedded sensors with the crops to help improve yield and to help make better farming decisions. So it's not just here in large cities where we'll be surrounded by self-driving cars, we'll also be eating food that was grown more efficiently. We may already be, in fact. Many of these things already exist today. And of course, when you think about the power of algorithms to change the world, I don't want to be a downer, but there are some military applications that I think have to be acknowledged, and we have to be aware that governments are certainly going to be using algorithms to remake the way they execute their military operations. So this one I found rather interesting. So in this example, the US Army, who frequently needs to do airdrops of supplies to troops, is actually using a new system that instead of GPS uses image recognition. So the system, which is of course unmanned, is able to look at the ground with cameras and look for the landing spot and guide the payload to a safe landing. And so that's, I think, an interesting use of an algorithm to make a more efficient and safer use case. Another interesting thing that's coming on from DARPA, which is an agency in the US, is a 130-foot unmanned robot ship. So this ship will be actually moving through the ocean with no one on it, looking for submarines. And that's about 40 meters. So I don't speak Korean, but I do speak metric. So just so you know, metric is better than the standard system, I can admit it. I don't know why America's stuck on feet, but it's a 40-meter ship. And actually, just 2 days ago, the first photos of the ship were released. So this is an actual photo of a 40-meter unmanned ship. So they will be, in just a few years, circling the globe, hunting for submarines. And I don't want to tell you what to draw from this as a conclusion, but simply that if we're thinking about algorithms changing the world, we can't ignore that they're going to have an impact on the military around the world. In fact, perhaps more controversial than this ship, there was a report yesterday that was released that said that some of the decisions on where to attack and who to attack from unmanned drones have been made by machine learning systems by the government. So, I think that's probably worth debating the value of that or the ethics of that. I'm not going to again tell you how how to draw conclusions on that, but I think it's safe to say this is being debated now. Many scientists are thinking about the ethics of how algorithms will actually impact our lives from a military perspective. And there are many countries that are researching and building autonomous fighting systems that actually go beyond just targeting remotely, but actually making these systems that fly or float entirely autonomous, able to make their own decisions. And I don't know if that's a great idea or not, but if you've read any sci-fi, I think you'll see that that doesn't always end well. But hopefully, if we're all aware of how algorithms are going to get used, we can make smart choices about it. And lastly, before I move off this depressing military topic, I just want to say that sometimes these systems actually go awry because of human error. So recently, there was an Army blimp that crashed into some power lines because someone forgot to load the batteries. So if you do decide to fly military aircraft unmanned, please remember to put the batteries in the blimp. Some basic rules. So on a more lighter note topic, if you are somebody who would rather make love and not war, there's actually a number of interesting developments in the world of finding love through algorithms. And in fact, I thought this was an interesting tweet. I do kind of like Twitter, if you haven't noticed. And this person I thought was very clever, and she said that within a few years, we'll be replacing our food with just nutrient-rich chemicals, and soon we'll actually be adding eyeliner to try to fool the algorithms into helping us find our match. So that seems pretty far-fetched. It seems like a bit of a crazy idea that might not ever come to pass. However, there are real-world examples today where something like this is happening. So Tinder is a dating app. I don't know if you've heard of it, but it helps you find the love of your life, possibly. Someone built a maybe not, I don't know. The love of your life might be in a watch. You may fall in love with this algorithm. But in all seriousness, this hack or prototype was actually designed to basically give a thumbs up to anyone when you're looking through this dating profile when your heart rate goes up. So that's a little bit of an algorithm helping you maybe find your Mr. or Mrs. Right. And there's another person who actually came up with an algorithm for helping you perhaps find someone that you would love. And this is also a Tinder moment. It was a swiping robot that actually does image recognition, tries to predict what you're going to find attractive. That may be a little superficial, but this robot has actually been prototyped and used in the real world. So I think you can see that the impact of algorithms on our society, our economy, is really just getting started. And I think ultimately, when you think about an algorithm being, at its most simple form, a way of solving a problem, and when you bring to bear the ability to compute, storage, and network all of this data that we're collecting and apply algorithms to it, essentially what we're doing is we're solving problems more quickly, much more rapidly. And that's why this 1,000-year-old idea is more relevant than ever. And then you may be wondering, what does all this have to do with OpenStack? We are at an OpenStack conference. So you'll of course be hearing about OpenStack throughout the day. But anytime there's a need to move data and transform data, that's a huge opportunity for a distributed system like OpenStack. This is actually another supercomputer, or another, distributed system at the University of Texas in Austin, where my good friend Jasek graduated. And this is a new cluster. It's going to be used by over 350 different universities all over the world, and it's all powered by OpenStack. And it is specifically designed for scientists who want to solve interesting problems in biology and agriculture, physics. These are really hard problems people are trying to solve. Alzheimer's research is going to be conducted through algorithms on these systems. So ultimately, I think OpenStack has a big opportunity to help solve the world's problems. And I look forward to seeing how all of you put OpenStack to work to solve problems. I think the world has plenty of problems, but we have a lot of promise as well when it comes to putting to work all of these trends. In terms of getting involved, there are a number of ways. First of all, the next OpenStack Summit will be in Austin, Texas in April of this year. And there are a number of different tracks and talks that are relevant to the algorithm economy and to telco, NFV, 5G, a lot of things we'll be hearing about today, containers. So it'd be wonderful if many of you can attend that summit. I'd love to take you out for Texas barbecue. We can compare against Korean barbecue. I think they're both wonderful. There's no right answer on that. We also have a scientific working group. I'll be posting these slides online if you want to get the links. But if you're involved in science or university research setting, you're using OpenStack for that type of science work, we have a whole working group that's collaborating all over the world with scientists. And then of course a number of mailing lists where a lot of active discussions happen with operators and other different segments of the OpenStack community. Also, would love to invite all of you to take the OpenStack user survey. This is open right now. It's really important to put your voice out there if you're using OpenStack or thinking about using it, to help us figure out what the next version should contain, how to evolve it to help solve big problems. And that URL I did not put on the slide, but it's openstack.org/user survey. So if you want, I will tweet that out. You can find it on Twitter if you want the link. But I'll also post these slides online. So we've talked a lot about algorithms and how they're going to affect transportation, agriculture, war, love, and many other areas of society. And so lastly, I just wanted to leave you with an example of what some algorithms are doing in the area of music. So this is actually a song that was composed by a number of algorithms that were trained in some of the basic tenets of how music is created and composed. But each of these little robots, if you will, or computers, were coming up with their own riffs and sort of responding in real time to what the other musician, if you will, or algorithm next to them was playing. And so this composition was entirely done by these algorithms learning in the field and trying to create music. Now, that we may not quite have the next Beethoven or Mozart yet, but I think it's kind of interesting, and I wanted to end on this video. So let's see if we can play this. Oops, sorry. thank you all very much. I hope you all go out and solve some big problems in the world using OpenStack and the algorithm economy. Thank you very much. I appreciate it.